Any comments on it? Do you have any comment on the solution to the assignment? Any comments?
Sir, I have something on question 2, sir.
Yes. What is that?
On the empirical formula, sir.
Yes.
In the atomic ratio, as you divide it, the first one is 1.5, the second one is 3.00, while the oxygen is 1. And when putting down the formula, I see C3H6O2. So that's where I'm confused.
In the solution?
Yes.
Okay, let's briefly look at it. I'm trying to open the. Does any other person have any comment on that? Any other comment from any other person? If there's no other comment, then let's just go ahead and can you see the solution now?
That's not showing. Yes, that's showing, sir.
Okay.
It's to show now. Is it showing now?
Yes.
Yes,
Yes.
sir. Yes, sir.
Now you are saying that question 2.
Yes.
What is the question again?
It says a certain liquid contain C4.
No,
C, which is 48.
the question you just asked now.
Yes. The question I asked there is that when we divide the atomic ratio, it's 1.5.
Yes. For carbon.
The other one is 3. Yes. The other one, which is hydrogen, is 3.00.
Yes.
The oxygen is 1. So from putting down the empirical formula, I saw C3H6O2. That is where I'm confused.
After the column for atomic ratio, the next column, do you look at it? Simplest ratio.
I look at it, but what I mean is that 1.5 is it you multiply it, or how do you get it to make it 3? That is where I'm confused.
Were you in the first class we had, or did you listen to the first video I shared with you, the first lecture?
I was unable to join on that day because my phone was at 40.
Did you say the video is still on the Google Classroom? Have you listened to it?
Yes, I see. Yes.
If you have listened to it, you will notice that the example we treated in that video is similar to this. When you have the atomic ratio of this nature, what you do, we have a fraction. The fraction is up to 5 and greater. You will multiply by a factor that will make it whole number. Are you getting my point?
Yes, sir.
You factor the whole thing by a whole number. I mean, by a factor that will transform the atomic ratio into a whole number. And that is what you have in the simplest ratio. In this case, the factor we use is 2. We multiply everything by 2. 1.5 by 2 give us 3. 3 times 2 give us 6. And 1 times 2 give us 2. That's why you have the 3H6O2.
Okay, that's what I want to confirm, sir.
Yes, exactly.
Because I tried it that way. I've seen it, but I want to confirm in case so that maybe if I want to do another one, to not make a mistake.
Yes, that's exactly the situation.
Okay.
Any other comment on this? Any other comment? If there are no comment on the solution to the assignment, it means by now you all know what you submitted. So you should be able to grade yourself on what you submitted for the assignment. Am I right?
Yes, sir.
Now, today, we shall look at factors affecting availability of electrons. Okay? Factors affecting availability of electrons. That is what I'm going to start with you today, but I'm not sure we'll be able to finish it because we have just about 20 minutes thereabout before we end the class. Okay. To do that, let me share this with you. Okay. Can you see my screen? Can you see it?
Yes.
Okay.
Yes, sir.
What? Can you all see the screen?
We have seen it, sir.
Okay. Let me close this so that it will. Okay. So we are discussing factors affecting availability of electrons. Okay. In this lesson, we should be able to identify the various factors that affect availability of electrons of organic compounds. We should be able to discuss these factors that affect the availability of electrons. And also, we should be able to identify and discuss the various applications of the factors that affect the availability of electrons of organic compounds. Now, when you're talking about the factors affecting availability of electrons, we are talking about the reactivity of these compounds. Okay, for a compound to be able to react, the electron, for any reaction to take place, some bonds will be broken, and another one will be formed. That is when the reaction takes place. A bond will be broken, another one will be formed. And we all know that it is electrons that made up bonds, especially in organic chemistry, it is the sharing of electrons. Okay, so if these electrons are not available, there's no way reaction can take place. Are you following me?
Yes, sir.
Now, one of such factors is what we call inductive effect. Inductive effect is one of the factors that affect availability of electrons. What do we mean by inductive effect? Now, I will illustrate what we mean by inductive effect to you. Look at this figure we have here, this structure. You see, it is carbon attached to another carbon. They are attached to, let's say, the other atoms are not shown, but let's assume they are hydrogen. Okay? If carbon and carbon, the bond between the two carbon atoms, is it polar or non-polar? I'm asking you, please. Yes, they are not.
Yes, sir.
This bond, the bond between two carbon atoms, is it polar?
I don't know.
What?
Said I don't know.
Why? Why wouldn't you know?
Ah.
You should be able to know. Sheriff Anko? Khadijat?
Sorry, sir. What is the question?
The bond, you have a compound in which carbon is bonded to another carbon atom. The bond between the two carbon atoms, is it polar or non-polar?
Yes, sir. Seriously, I'm not sure.
Munira?
This is not funny.
Asisa? Yes, Asisa?
Yes, sir. It's not polar.
It's not polar. Yes. Can you
Yes,
tell
sir.
us why it is not polar?
Because the hydrogen atom attached to the carbon atom are in the vertical horizontal direction. I attached straight to the carbon atom.
I think I can answer that, sir.
Who is that?
They are not.
Oh yeah,
It's
Mungo.
because of the electronegativity of the hydrogen and carbon.
Is that all?
Yes,
Yeah, I don't know where hydrogen comes in here. I'm asking the bond between carbon and carbon, not even hydrogen.
you said there are some things missing.
I said the hydrogens are not shown, other atoms are not shown. Because we are
They are not-
concentrating on the two carbon atoms. Yes. Oh yeah.
Actually, sir, because of the electronegativity of carbon, they are not usually most general knowledge is that they are not a polar covalent bond, sir.
Generally, hydrocarbon, they are non-polar. Okay.
That's
why
why
are they non-polar? Listen, please. Why are they non-polar is because this is carbon atom. Here you have another carbon atom. It's carbon all through. Carbon, this carbon and this carbon, are they the same or different?
They are the same.
They are the same. The electronegativity is the same thing. They have the same electronegativity. Therefore, the bond is not polar because they are the same kind of atoms. Who is that disturbing us? Because you have carbon and carbon, the same kind of atom, the electronegativity is the same thing. The bond is not polar. It's a non-polar bond. Okay? Even if you have hydrogen attached to it, quite all right. Hydrogen is different from carbon. Okay? But hydrogen and carbon have almost the same electronegativity. They have almost the same electronegativity. Therefore, the bond between carbon and hydrogen is also non-polar. And that is why generally hydrocarbon, they are non-polar compounds. Do you get that now?
Yes, sir.
Okay.
Yes, sir.
Now, if you look at the second structure, here you have a carbon atom attached to a more electronegative atom. The atom that is represented by X is more electronegative than carbon. You can also see that it's even different from carbon atom. Because this atom is more electronegative, the electron will spend, the bonding electrons we spend more time with this atom. Therefore, this bond is polarized. Okay? The bond between the carbon and the more electronegative atom is polarized. And that electronegative atom will have partially negative, and carbon will have partially positive. In this case, we say we have dipolar. Are we in order? Are you following me, please?
Yes, sir.
Yes, sir.
Okay. Now, an example given here, the example given here is that of fluorine. Here, look at it. Fluorine attached to carbon atom. We all know that fluorine is more electronegative than carbon. Okay, and that is why you have fluorine here being more electronegative, being partially negative, and carbon being partially positive. Okay, and that is the explanation given here, that in the alkyl halide above, the carbon fluorine bond is polarized towards the fluorine atom, meaning that there's more electron density towards the fluorine end of the bond. Toward that end of the bond. This imbalance of charge represented above by this of partially positive and partially negative. Now it now goes that before I go to that, in this situation in which we have fluorine and carbon joined together, we described that fluorine is pulling the bonding electron towards itself. Okay, fluorine is pulling the bonding electron towards itself. That is why fluorine is partially negative and carbon is partially positive. In this situation, we call it inductive effect. Okay, inductive effect. And the definition is given here. This is the induction of polarity or dipole in an otherwise non-polar bond, and consequent electron shifts along a chain of atoms is known as inductive effect. Okay, shifting of electrons in a chain towards a more electronegative atom is what we call inductive effect. Okay, now this effect, no matter the length of the chain, the inductive effect will be transferred along the chain. Okay, now the example we showed the other time was of just carbon and fluorine, but if there is another carbon attached to that carbon, it will also feel that pulling of electron. It also feels the pulling of electron. That's what we are illustrating here. Look at here. We have chlorine atom at the end of the chain here, and we have carbon atom. The inductive effect is felt along the chain like this, because chlorine is pulling electron toward itself. The pulling of electron is also affected by this carbon and this carbon, and so on like that. But in a normal situation, the inductive effect diminishes. Okay, it's negligible after the fourth carbon atom. After the fourth carbon atom, and that is why we use this arrow to represent inductive effect. This carbon is the one that is more affected by the inductive effect. This one is also affected, but it is not as affected as this carbon, and it reduces as you go down like this. Here, this one is partially negative, and this carbon is partially positive. This delta means the partial positivity reduces as you go down like this. Are you with me, please?
Yes, sir.
Okay. Now, a situation of this nature, where you have an electronegative atom pulling electron toward itself, okay? And the pulling of the electron is being felt by the chain of carbon atom. It's also referred to as negative inductive effect. What do I call it?
Negative inductive effect.
That is what we call negative inductive effect. There is a situation in which if you have a metal atom, if you look at this chart here, if you have a metal atom attached to a carbon chain, okay, carbon is more electronegative than metal. So carbon will be pulling electron from the metal towards itself. Are you following me, please?
Yes.
Carbon
Yes.
will be pulling electron towards itself. In this situation, the electron flow is toward carbon atom. Okay? In that situation, we say we have positive inductive effect. Okay? Positive what?
Inductive effect.
Now, look at it this way. In this other case, electron is being pulled is toward the carbon chain. That is positive inductive effect. Here, electron is being pulled away from carbon chain. That is what? Negative inductive effect. Okay. So that is inductive effect for you. Inductive effect can be positive or it can be negative. Okay. Now, inductive effect, the symbol for inductive effect is a capital I. I think I didn't indicate that. Inductive effect is represented by a capital I with a negative sign, like this. This is the symbol for inductive effect. Okay? I hope you can see it. So this, if anywhere you see a high with a negative sign, it means you have a negative inductive effect. But for positive inductive effect, we use also I with a plus sign to represent positive inductive effect. Any question, please?
No question.
No question.
Yes, sir.
Okay. That means we grasp the jargon we have been saying all along.
Yes.
Okay. Now, inductive effect has okay. Before we go to the application, there's another effect known as field effects. Field what?
Effects.
Field effects.
Field effect.
Field effects is the same thing as inductive effect. Okay? The difference between field effect and inductive effect is that field effects occur in solution or in the gaseous phase. Now, let me read this note here. An effect which is similar in nature to the inductive effect operates through the space surrounding the molecule, or if in solution, through the solvent molecule surrounding it. Are you getting it now? That is,
yes.
If inductive effect is through space or through solvent, then it is known as field what? Field effect.
Effect.
Okay. So it's the same thing as inductive effect, except that it's either through space or through solvent. Now, we can, atoms or groups, they have been identified according to their the strength of the inductive effect, the strength of how they can pull electron towards themselves. Okay, such we have, if you look at the first chart here, you see that hydrogen is less than phenyl. Okay? Phenyl is less than hydroxyl. Hydroxyl is less than iodine. Iodine is less than bromine. Bromine is less than chlorine. Chlorine is less than fluorine. Fluorine is less than carboxyl. This is the carboxyl functional group. Carboxyl is less than cyano or cyanide. Cyanide is less than nitro in negative inductive effect. Okay? In negative inductive effect. So if you look at this chart, it will tell you the strength of inductive effect. Now, even like the other one here, we have hydrogen less than deuterium. This is deuterium. Deuterium is less than methyl. Methyl is less than primary alkyl. Primary alkyl is less than secondary alkyl. Secondary alkyl is less than tertiary alkyl. And tertiary alkyl is less than carboxylate ion. Carboxylate ion in positive inductive effect. Meaning that if you have any of these attached to carbon atom, they will donate electrons to carbon. But if you have any of the one at the top attached to carbon atom, they will pull away electron from the carbon atom. Okay?
Sir.
Do you understand, please?
Yes, sir.
Now, already it is 6:30 p.m. In our next class, or maybe I will try to make the video and send it to you to discuss the remaining part of the lecture. The next thing we should be talking about is the applications of inductive effect. But we'll leave that for a later date. Okay? Is there any question so far, so good?
I have a question.
Yes.
You said that field effect is just inductive effect that is operating through space or through solvent. Does that mean that inductive effect itself is operating in solids?
No. Inductive effect is, operating when you have an electronegative atom attached to a carbon chain. Okay? Now, if you look at the example we show above, let me show you. Okay, look at this example here. You can see that this metal atom is attached to this chain of carbon. Okay? In this case, you have direct inductive effect. In this situation, positive inductive effect. But when you say field effect, that atom is not attached to carbon chain. But because it is in proximity of another molecule, which is more electronegative, and there is a way it can come in close contact to it. So it can also affect the carbon chain to pull away electron or to donate electron. That's what you have field effect. How do you get the reality?
I don't, sir. But I think what? Let me try to like say it the way I get. Now it means that whenever we have a neutral atom, that is when we have inductive effect.
Sorry,
like when we have atoms of metal with carbon, that's when we have either a positive or a negative inductive effect. If I'm
no.
right.
When you have an electronegative atom attached to a carbon chain, for example, if you have bromoethane, okay, bromoethane, bromine is attached to ethyl. In that case, you will have negative inductive effect because bromine will be pulling electron toward itself. Even if you have bromopropane, you still have negative inductive effect because bromine will be pulling electron toward itself. Okay? But for example, if you have zinc, for example, attached to propane, no, zinc is a metal atom. The zinc, instead of pulling electron, will be donating electron to the carbon chain. In that situation, we have positive inductive effect. Do you get that now?
Yes, sir. But sir, can you just give illustration like you did for inductive effect for
what?
Like you did for inductive.
I can't hear you.
I said that. Can you please give illustrations like you did for inductive effect for field effect too?
Field effect.
I'm trying to say that you gave illustration for inductive effect, like we have carbon atoms like that in bond and then bonding to a metal. You gave that illustration for effect. It gives something like that to explain that one more better. You just said they are operating with true gases or true solvents. That's the only thing I don't really get that part of.
Okay. I will let me, what do you call it? The illustration for field effect, I will leave for a later date. Is that okay?
Sir?
Is that, I will leave the illustration till a later date.
Oh, okay, sir.
Okay. Any other question? Any other question? If there are no other questions, can we call it a day then? Yes, you are not, people are not saying anything. Sola, you can't see you again. You are in a dark place. Then we can't see you too. Steven. Any question?
No question.
When is our next meeting? Friday. Is our next class Friday?
Okay, sir. Friday.
Fine, sir.
Friday and Thursday, I think so.
Thursday and Friday.
I think,
which day?
I think on the timetable was Thursday, I think so.
The timetable is Friday.
Yes.
Not Thursday.
And what is the time, sir, please?
What is what?
He's asking
the
for the
time
on Friday.
Time for the class, sir.
Yeah, normally it's supposed to be 5 to 6 on Friday. But because I have another lecture 4 to 5, that's why we extend the time to 5:30 to 6:30.
Okay, so we should be maintaining that 5:30, Abi.
Yes, unless you have alternative time that you think we can be meeting.
That Friday is okay, sir.
The Friday is okay, sir.
Friday is okay.
Yes, sir.
Yes, sir.
So if that is the case, we can call it a day for today. For today's class, I can see only 11 of you around. One person has disappeared, making 10. Okay?
Okay, sir.
So
Good day, sir.
until we meet again.
Okay, thank you.
Okay, sir. Thank you, sir.